In the last video, we saw that parallel lines have the same slope, and two lines with the same slope must be parallel. Let's talk about the connection between the slopes of two perpendicular lines. Well, to give you an idea of what happens, let's say that we have the first perpendicular line, one line, so here you have the x-axis, here's the y-axis. Let's say that you have a line with slope a third. So going through the origin. Okay. And suppose that you have a line that's perpendicular to it. So this is line L1, that's line L2. And the question is, what's the slope? So if L1 and L2 are perpendicular, and L1 has a slope of 3, what is the slope of L2? Well, remember what it means for a line to have slope a third. What it means is that whenever you take 2 points on the line and look at the line segment on that line, the slope of that line segment is 1/3. So let's say that you take, say, the origin here and this point. So let's call this point A and that point B. So since L1 has slope a third, the slope of AB is 1/3. That means that if you take, again, let's drop a vertical line down B. If you look at this horizontal length here, and this vertical length here, the blue length, so let's call this point C. Okay. So since L1 has slope 1/3, BC over AC is 1/3. Now what happens if you imagine rotating this triangle 90 degrees clockwise? So if you imagine rotating L1 by 90 degrees, well, if you take L1 and rotate 90 degrees, what line are you going to get? You're going to get L2 because L1 and L2 are perpendicular. So, and what happens to, so imagine rotating L1 90 degrees clockwise. Then L1 turns into L2. And what happens to the horizontal and vertical line segments? Then this horizontal line segment AC turns into, after you rotate, if you have a horizontal line segment and you rotate 90 degrees, what does that become? That becomes a vertical line segment. And what happens to BC? BC was a vertical line segment. When you rotate a vertical line segment by 90 degrees, what does that turn into? It turns into a horizontal line segment. Right? So Now A is the origin, A is just going to stay there, but B is going to go to some other point, B prime. See, this whole triangle ABC is going to be rotated by 90 degrees. So B will go to B prime, and C will go to C prime, which is directly below A. And this triangle, see, this line segment AC will become this vertical line segment AC prime. And BC will turn into the line segment B prime C prime. And remember, we are trying to find the slope of L2. Well, this line segment AB prime is on the slope L2. So, what is the slope of AB prime? Well, we take 2 points and we find the vertical change divided by the horizontal change, right? Suppose that AC were equal to 3. Then what would BC be equal to? BC would be equal to 1 because L1 has slope 3. Slope 1/3, sorry. So then AC prime would have length 3 and B prime C prime would have length 1. And we're trying to find the slope of L2. Well, L2 is going down, so is that going to be a positive or negative slope? Is the slope of L2 positive, negative, or 0? It's negative. You take the vertical change and divide it by the horizontal change, so the slope of L2 is 3 over 1, but it's not exactly 3 divided by 1. It's negative 3 divided by 1. Because remember, when you have a negative slope, the slope is negative 1 times the slope of the vertical segment divided, the length of the vertical segment divided by the length of the horizontal segment. And negative 3 over 1, that's negative 3. So the answer was the slope of L2, it's negative 3. So let's summarize why this is true. Because if you have a slope of, say, 1/3 for L1, then when you rotate clockwise by 90 degrees, L1 will go to L2, B will go to some point B prime, and you can find the slope of this line segment AB prime. And since the horizontal line turned into a vertical line, and the vertical line turned into a horizontal line, then when you calculate the slope of L2, see, you ended up taking the reciprocal, 3 over 1, except that there's also a minus sign because now the slope of L2 is negative. So that basically gives you an idea of what's going to happen in general. What happens if L1 has slope of 1/4? Then the slope of L2 will be negative 4. And in general, so the theorem is, if two non-vertical lines are perpendicular, then the product of their slopes is negative 1. Notice in the example, 1/3 times negative 3 is negative 1. Okay. And the converse statement is also true. If the product of the slopes of two lines is -1, then the lines are perpendicular. Because if you had one line with, say, slope, let's say that one line had like slope 4, and another line had slope -1/4. How do you know that the angle they make is 90 degrees? Well, if you take, say, this origin, okay, where they intersect, and take, say, this point here, let's call it B, so let's call the origin A, okay. Then you know that, okay, let's say that you take this point C, and suppose that AC was length 1, say. I mean, it doesn't actually matter, but let's pretend that AC has length 1, and then BC has length 4. Well, you know that if you take the triangle that's 4 to the right and down 1, you get this triangle like this. So let's call it D and E. Okay. So this length DE is 1, and then this length AD is 4. Or you could, to make it a little better, you can make it this point down 1. So let's call this maybe F, and then this point to the right 4. Okay. Then this triangle and this triangle, when you rotate it 90 degrees, you'll end up getting from one triangle to the other. And that explains why L1 and L2 make a 90-degree angle with each other. Okay. That's what I wanted to say in this video.